Major support for Do the Math has been provided by Chevron, California Resources Corporation, Edison International, Center for Neural Skills, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, Tuolumne County Superintendent of Schools, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Mary Lou.
And I'm Colby. For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. The Do the Math email is dothemath@kern.org. We're online at dothemathonline.net and on social media platforms.
All right, thank you for doing that, Colby. So where do you attend school?
Stockdale Elementary.
And what grade are you in now?
5th grade.
What is the best thing about 5th grade?
Probably the field trips to the edible garden.
Oh, good. All right, so you like the field trips. Mm-hmm. And I'm sure you're going to have an opportunity to go on field trips a lot during the rest of your schooling years.
Yeah.
Is there anything that has given you difficulty as far as math so far in 5th grade?
Not really. Some of the writings, but that's really it.
Okay, but everything's been pretty smooth so far. Mm-hmm. All right, good. So are you involved in anything extracurricular at school right now or outside of school? Because I know in 5th grade you get an opportunity to do a lot of different things.
I'm in gate, I do valet. That's really it so far.
Well, those are two things, right? So it's not like you're not doing anything, right? So you're doing two things, so you like both of those. How do you like doing social media problems of the day? Have you ever done one of those?
No.
Oh, guess what? Today's your big day because we're going to do one right now. You ready?
Okay.
All right, let's take a look at it together. All right, can you go ahead and read that for me, please?
Which group has all prime numbers?
So what do you know about prime numbers, first of all?
Prime numbers are one in itself.
Good. So let's take a look at those options and tell me what you're thinking about as you look at each one. So when you look at option A, what do you think about that?
Most of them, I think, can only be added, wait, let me think, one in itself. Yeah, I think most of them.
Most of them what? Are prime?
Yeah.
Okay, but are all of them prime?
Let me think.
Because you said one and itself.
One in itself, yeah.
So can anything go into 5 other than 1 and 5?
Wait, no.
No. What about 19? Can anything go into 19 besides 1 and 19?
No.
What about 21?
No. Wait. Maybe?
Yeah, maybe, right? Well, let's move on. All right, let's go to B. What about 3? Can anything go into 3 besides 1 and 3?
No.
What about 7?
No.
What about 15?
Yes.
What can?
Wait, no.
Nothing can go into 15 besides 1 and 15?
No.
I want to add one thing I just want to ask you about are your 3 times tables. What's 3 times 1?
3 times 1 is 3.
3 times 2?
3 times 2 is 6.
3 times 3?
9.
Times 4?
12.
Times 5?
15.
Times 6?
What is it? 3 times 6? Oh, 18.
Times 7?
21.
Okay, now let's take a look at A and B again. Do you think anything can go into 21 besides 1 and 21?
Yes.
What do you think?
3 and 7?
There you go. What about B? Can anything go into 15 other than 1 and 15?
Yes.
What?
3 and 5.
See, dude, you just had to recall it again real quick, right?
Yeah.
So right now we can say A and B are out. All right, let's take a look at C. We know 1, 3, and 5 are prime. What about 18?
18, you can do 3 and 6.
Right, everything happens to have a 3 as a factor of it so far, right? So let's go to D. There's our great number 3, right? So let's take a look at those numbers. Can anything go into any of those numbers other than the numbers themselves?
No.
All right, so out of all of those options, which one do you think has all prime numbers?
D.
You're perfectly content with D. All right, let's take a look and see if indeed you are correct. There you go, dude. First one all done. All right.
Okay. Nice
So
job.
congratulations on that. D is the one with all prime numbers. 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. And in studio, we have Yvette with us, and you are with the Water District, correct?
Oh, city's water department, yes.
The city's water department. And is there anything more specific than that? Like, what is your role with the department?
My role is assistant water director. However, I oversee the wastewater division. So the water department, water resources, wastewater division.
Okay, and today we're going to talk about wastewater.
Correct.
Right, because it's something that people do every day,
Yes.
but they don't think about it every day.
No, not most people know.
Right, because
Yeah.
I mean, everybody uses the bathroom and then they use the toilet, they flush it, but then you don't really give it a second
That's it.
thought.
Out of sight, out of mind.
But you guys need to give it a second thought, and quite
yes.
often a lot more thought than just a passing thought.
Correct. Yes.
So what we're going to talk about is understanding the sewer system, and I know we've got a couple of slides that we're going to go through here right now.
Yes.
All right, so let's go ahead and take a look
Okay.
through them.
Let's go ahead. So understanding the city's sewer system. Quick overview just of everything that we do. So as we mentioned, usually people don't think about anything once they use the toilet. So starting off, what is wastewater? Wastewater is everything that makes its way down the drain. So if you brush your teeth, wash some dishes, shower, use the toilet, do a load of laundry, absolutely everything is wastewater.
Okay.
Makes its way down the drain. So what happens after you do any of those things in your home? We have a sewer collection system. It's a system of pipes underneath our streets that we really don't think about. The city of Bakersfield has over 1,100 miles of sewer pipe. All of that makes up our collection sewer system. So you flush your toilet, it makes its way into the collection sewer system. We try to have wastewater flow by gravity. It's a large
Right,
volume.
it's the easiest thing to do.
Easiest thing, flow by gravity, but eventually it gets to a low point. Every part where it gets to a low point, we have a lift station. Pumps it up to an elevation that once again, it can flow by gravity to the next low point. Wastewater keeps doing this, lift station, high point, low point, all the way until it makes it to one of two treatment plants that the city has.
Okay.
So city has 1,100 miles of sewer pipe, 56 sewer lift stations, 2 wastewater treatment plants. One thing to note, it's wastewater, but we also deal with stormwater. Some cities have combined systems. Wastewater and stormwater make its way down the same pipes to the same locations. We do not have that. So in addition to the 1,100 miles of sewer pipe, we also have about 1,000 miles of storm drain pipe.
And people might get confused about that because
Yes.
we don't have storms here in Kern County a
Correct.
lot, but it's always water runoff.
Yes.
Okay.
Yes. So we also have that system to look after. But again, we have separate. So looking into wastewater basics, what is wastewater treatment? We typically look at 2 components, the flow, the liquid portion, and the organics or the solids. Treatment in our facilities have a primary, secondary, and tertiary treatment.
Okay.
Primary is basically we're trying to get rid of all, the first step is screenings. There's a lot of things that make its way down the drain that really don't belong there. Plastic products, flushable wipes that really are not flushable.
Right, and they say on the package, please
Correct.
do not flush and
Yes.
things like that. And a lot of businesses also state that.
Exactly. And then there's some other random things that make their way down into the storm drains, more through the manholes, but we get tires or blankets or large toys. All of those items we need to get
Kids
them.
have fun when they discover the toilet and drains and what
It's
can go down
amazing
there
what
and
they
things
send
like
out.
that.
Yeah, so all of that we try to screen out at the beginning so it doesn't damage the equipment downstream. Then we go into grit removal. That's more of like eggshells or pieces of sand that
Yeah,
make
we
their
can
way.
see that on the flow chart that you've got there.
Absolutely, yes. And then we have primary clarification. This is the first step where now we're getting rid of some of the organics that do belong in the system, but they're organics, they're solids, and we are trying to remove them.
Okay.
From there, aeration tank. This is part of our secondary treatment. It's where we start doing the biological treatment. Into the secondary clarification tank. So all of the steps really are just, we're trying to separate the solids and the liquids at every step, and increasingly more so. Our tertiary system, that is, our tertiary treatment, that is a final filtration step. And then there's a disinfection. So once it goes through the tertiary treatment, we have now produced reclaimed water or purple pipes, so it can be used to irrigate landscape at that point. If we just kind of stop at the secondary, which some of our processes do, it's used to percolate back into the groundwater or for agricultural irrigation.
Okay.
So different types of use. And then as we mentioned, the solids. So every step we have removed, try to separate. Our solids go into sludge digesters, which are basically huge concrete structures that get heated up to 100 degrees Fahrenheit and get digested for about 15 to 21 days. The end product, it kind of looks like, what's
Sludge?
it? Not sludge. I'm drawing a fertilizer. Sorry.
Okay.
Fertilizer. It kind of looks like fertilizer at
Okay.
the end, and then it's land applied to city-owned farm fields. So everything has a beneficial use one way or the other. Just a quick overview of our system. This is all the colored portions on this map. All of that gets treated by the city of Bakersfield. Right here indicated in the square, that is our Plant 2 treatment plant. Plant 2 was initially built in 1939 and has had 3 major expansions. It's currently a trickling filter treatment process.
Okay.
Here we're comparing the design criteria. So we try to keep track of the liquid and the organics or the solids. Flow, it's designed for 25 MGD, million gallons per day. If you want to visualize that, 1 million gallons of water, picture yourself in the middle of a football field. Picture that football field with 2.5 feet of water. That is 1 million
That's 1
gallons.
million. And you've got 25,
I've got 25.
able to go through. Okay.
Suspended solids. It was designed for 327 milligrams per liter. Sorry, but where'd it go? 327 milligrams per liter. Biochemical oxygen band, 251. Our actuals, we're doing pretty good on flow, but our organics, our solids loading, it's higher than it was designed for. So that is a
which
bit
is
of a
why
concern.
things need to be fixed and updated, because we
Absolutely.
can see if we take a look at the dates when they had expansions, it's
Yeah.
been quite a while since the last one.
And it usually takes a while between when technology is developed and when it's implemented. So trickling filters were really a high point in around the 70s. But as you can see, we went ahead and introduced it. I'm sorry, I keep doing this. Introduced it in '97, so it was already a little bit behind. I don't know.
You got
if
the
this
magic
keeps going
touch, Yvette. Every
forward.
time you hit that, we go back in time a little
Is
bit.
it the
See?
touchscreen? Oh my gosh. Okay, that's what it is. Here's an overview of just sort of the layout of Plant 2. This is our headworks, it flows, and these are our trickling filters. That's the technology and secondary clarifiers. So everything flows through. Going on to Plant 3, again, this is our service area. Plant 3 is everything on basically the west side of the 99. A little different story with Plant 3. It was built in 1970, has had 4 major expansions, the last one being in 2007. Here we have an activated sludge treatment process. So a lot newer technology compared to Plant 2. You see the design criteria, it's a little larger, 32 MGD with 333 total suspended solids concentration, 500 BOD. So our actuals were pretty good on the solids, but here a different story. It's the flow that's a bit of a concern. We're at 21.2, which is roughly about 66% of the design capacity.
Okay.
Once we hit 70% of capacity, we need to really look at an expansion.
Right, what's going, because you don't want to get it past that, because that's
Exactly.
when problems start happening more.
Yes.
Okay.
And then just a final look. This is a much larger footprint than our Plant 2. You can see this is just the first half of the treatment process. It didn't all really fit into one photo. So that really is sort of a summary of what is wastewater and our treatment process for the city of Bakersfield.
Well, fascinating, because a lot of that stuff is going on, and I know it's been in the news pretty recently
Yes.
and things like that. So anyway, Yvette, I know that you would love to do a lot of the math problems that go along with that, but I
Yes.
know you brought a colleague in.
I
We're gonna have
did.
him
I
do
wanted
some
to
of those
spread the fun.
math problems a
Yeah.
little bit later on. But Yvette, thank you for coming in.
Thank you so
We'll be
much.
back with more right after this. All right, our mathematician today is an ancient Greek mathematician, Eratosthenes. Eratosthenes is best known for calculating the circumference of the Earth, and that was quite a feat a long time ago. He also developed a procedure to find prime numbers, also known as Eratosthenes' sieve. Prime numbers, different than composite numbers. Prime numbers have only 2 divisors, 1 and the number itself. That's it. Composite numbers have more than 2 positive divisors. So let's take a look and see how even numbers can be made of 2 primes. So in 1742, Another mathematician, a German mathematician named Goldbach, conjectured. So when you make a conjecture, and you hear it a lot of times, they go, well, my mathematical conjecture is. So they're guessing, they're surmising, they're kind of taking a different approach to it. They don't quite have it proven yet, which is why it's a conjecture, not a theory. That every even number except 2 is the sum of 2 primes. Although many brilliant persons have studied this problem, it has never been proven or disproven. So we're going to take a look at his conjecture for these even numbers by expressing them as the sum of 2 primes. So 6, we need to make it 2 prime numbers. So obviously we can go 1 and 5, those are 2 prime numbers, and we can also go 3 and 3. You can't go 2 and 4 because 2 and 4 are not both prime numbers. 10. So think about 10. What ways can you make 10 using prime numbers? Well, we know 3 is a prime number, and we can add 7 to it. Is there another way to possibly do that? Well, 5 is also prime, so we can do 5 and 5. So the number 14. Let's keep going with the 3s. We'll see how far we can get with 3s. 3 and 11. So that one will work. Is there another way to do 14 other than 3? Well, here we had doubles of 5. If we take the next one, 7 and 7. So now let's take a look at 18. Can we continue with our 3? Well, if we put 3 here, we're going to need 15. 15 is not a prime number, it is odd, but you can do 1, 3, 5, and 15, which makes a composite, not prime. So we can't continue with our 3, but let's put a 1 in front of it, have 13. 13 is prime, 5 is also prime. 28, we could do 11 and 17, those are both prime numbers, but 28 we could also do 5 and 23. And since 23 is one of our favorite numbers here on Do the Math, we're going to stop at 23. You can try 40, 64, and 100 and see if you can come up with 2 primes to equal each of those numbers. That is our mathematician of the day in ancient Greek, Eratosthenes.
Did you know that the subtraction symbol has been used since the ancient Greek and Egyptian mathematicians? Back then, there were multiple ways to represent subtraction, but the one we use today became popular in Europe in the 16th century and has stayed popular until now. Now you know.
And thank you to Caitlin for that Now You Know. In studio with us, we have Colby, a 5th grade student, and you were working on prime numbers for our social media problem of the day. We just learned about Eratosthenes and the prime numbers that he was using. And guess what you're about to do?
What? The same thing?
Prime numbers. You ready?
Yep.
All right, head on
Okay,
over to the board.
come on.
All right, so here's how this is going to work, Colby. In the center, you see the number is 61. Okay? 61 is a prime number. You have to use the 3, the 4, the 5, and the 1 to somehow get to the number 61. Go.
Ooh, how can we get there? Can we use all operations?
You may use all operations, but you may only use each number once.
Okay, so what are you thinking, Colby? Where would you like to start?
5 times 4, because that's going to get the biggest sum.
Okay, so you're saying, I'm going to scribe for you. So you're going to say, because that's going to give us the biggest product, right?
So it's 20.
Okay.
And then,
So we've used the 5 and the 4. Can I cross those off?
yep.
Okay.
And then you times it by 3, and then you add the 1. which is
Oh,
61.
tell me why you're timesing that by 3.
Because 20 times 3 equals 60. And then you add the 1, which is 61.
Ah, oops, I forgot that one. Let's see if I could erase that. Forgot the 0, didn't I? 60 plus the 1 gets us,
61.
boom.
There you go, 61. So now here's the challenge for you. Is there another way to do it besides that?
All right, let's think. So there's our first way. Let's keep that. You got that one? I got that. Oh, here, I'll let you. There you go.
Let's try 3, wait. Oh yeah, 3 times 5.
Okay, what's our product?
3 times 5 equals 15.
Okay.
Times 4, which equals 60.
Ooh.
And then add the 1.
And then add the 1.
Equals 61.
Wow. Nice.
There you go. Nicely done. So that was done well. So I'm
Yes,
glad
it
you were
was.
able to do it 2 different ways, because there's a lot of times people go, well, you know what, I can do these 5 problems. And that's great. But if you can do one problem 5 different ways, that's even better. All right. So you being able to do that problem 2 different ways shows that you've got a better understanding of how to do that
You have
problem.
that flexibility with the
So
numbers.
on the other side of the board, so Mary Lou, I'm going to have you write these numbers down for me.
Okay.
All right, so this is going to be part of what you brought in as far as your homework goes. We don't have to deal with prime numbers right now,
Yeah.
okay? So here we go. Mary Lou, 3.61, 9.
Next to the.
No. Sorry. Just go, separate them somehow. So
Okay.
we have 3 and 6100ths, then we have the number 9.
Okay, can I do it with the
And then we
comma?
have 5 and 2/10.
And 5 and 2/10. Okay.
All right, so Colby, what I'd like you to do is solve that, and you can do it any way you want.
Add
There's a
them?
lot of different ways to do that, so
Or-
add them.
Okay.
How do you want to put those together?
So you start with, so you do 9, 0, 0 plus 361, which equals,
So can I ask you, I know you're thinking,
Yeah.
but why did we turn our 9 into 900? Oh, okay. So you were making this as the decimal, so you have a place
Yeah.
for a place value, okay?
and then you put the dot right there. So 1261 plus 5.20, which equals 8171.
So I found it really interesting, and I noticed that. Tell me more about how you're lining your decimals up and why.
So, what do you mean by that? Like,
Well, why are these all in alignment? Here, why are your decimals all lined up? So what column is this? Do you know what place value this
the
is?
hundredths,
Oh, that's hundredths. That's the,
tenths,
and then we have to line up our decimals, right? And then we have our
ones,
ones, and then over here in our
tenths.
cents. Okay, so you added those, right? So what's another way I can combine these numbers besides adding? What else could we do with those? Could you use 2 different operations this time? Okay. What would that look like?
You could do order of operations, maybe.
Okay. How would you do order of operations?
3, 6, 1, plus 5.2. What's about 2? And then parentheses, and then add 9.
Okay. So now we're still doing the addition, right? Are we going to come up with the same sum of 17 and 8100ths?
Probably.
Okay, so it's almost like that associative property, commutative property, right? We're switching numbers around. So let's think about this with another operation. Right now we just have adding.
Yeah.
What other operation can you bring into this? Do you want to bring in subtraction? Do you want to bring in multiplication? Do you want to bring in division?
How would you do subtraction?
Oh, subtraction. How would you do subtraction? What would that look like if we brought in addition and subtraction? And you talked about order of operation. Would you like to add first and then subtract, or would you like to subtract and then add?
But where would you subtract?
I don't know. What 2 numbers would make sense to you to subtract?
Wait. 5.2 minus 3.61.
Okay, do that.
5.2 minus 361.
So what are we going to do here? We have 0 minus 1, right?
0 minus 1, so you take that one.
So you're regrouping.
Yeah, but that one doesn't have enough, so it's 1, that one's 4, that one's 11, that one's 10.
Okay.
10 goes into 1 9 times. 5, and 1. 1.59.
Okay. So we have 1 in 5900ths. Now what are we going to do with this? So you subtracted, right? So now what can we do with this? What number is left?
9.
Okay, so what are we going to do with the 9 and the 1 and 5900ths?
Subtract it.
You want to subtract it again? Okay. You could write on over here.
1, 5, 9, and then 9, 0, 0. And then you take 8, 9, 10. 10 minus 9 equals 1, 4, 7.
So what's our final?
714.
Okay.
741.
So here you've done addition, right? And you did addition in 2 different ways.
Yeah.
I love your parentheses. Tell me something about parentheses. When you use parentheses, what does that mean you're doing?
Order of operations, and you're doing that one first.
You're doing, but it's isolating it. Is it isolating it? Okay. And then here you decided we're going to subtract both ways. Could we add and subtract?
You could, but you guys have
We did.
pretty much taken care of
We
that
got
problem
taken
right
care
there.
of
So
that.
nicely done. So Colby, come on
Good
over
job,
here. I've got
Colby.
an important question for you. Do you have a favorite flavor of ice cream?
Probably cookies and cream.
Cookies and cream. You know what? I know somebody in my house that also loves cookies and cream, so that's a nice selection right there. Do you know where you can get some excellent cookies and cream ice cream?
Sweet
That's
Fix?
right, Sweet Fix Creamery. You were right on line with me. I knew you were going to say that one right there. Plus, they have a lot of other flavors. November just started. They have new flavors every single month. So for doing some great work over there, you've got yourself a free ice cream courtesy of Sweet Fix Creamery. So nicely done. We'll be back with more right after this.
I'm Nancy Gordon. I'm the Director of the Health, Safety, and Wellness Department with Panama Buena Vista School District. This is another tool of mathematics, a Snellen vision screening tool. So oftentimes as you come onto a campus, you will see this vision box located either in a health room or in a classroom if we bring in the students to have their vision taken. You will see on this chart the numbers or the letters. You can see it in both ways. They start a little bit larger and then they work themselves down. You'll hear folks speak a lot about what's my vision acuity. And what we're looking for with students is a 20/20 vision. We want to make sure as students are sitting in those classrooms, they're able to see the board and also see the material in front of them as they're reading their books. So we have students come into a room with our nurses on staff, step about 10 feet away, we'll put a marker on the floor, and then we'll have them cover one eye. And then as they're covering that one eye, we are checking to see the acuity in the eye that's exposed. So when we're looking at vision screening, we want to see again that 20/20. And when you look at this chart, the markings are over to the side. So 20/20 is all the way down here, which is where we want students to see. And when you're looking at that for vision, you want to be able to say at 20/20, that student's able to see at 20 feet and they're seeing this 20 sized graphic that's provided on the screen. So as you are unable to see those, we'll ask you to go up line by line until we're able to identify that you can see that line with clarity. So once we know that that's where your vision is, if it's in a zone that we feel like you may need some support so that you're seeing that much more clear, we will have your parents take you to your eye doctor and have your eyes checked. Again, this is another tool that we use in the school setting to screen our students' vision so that we make sure you're able to see as you're in the classroom.
And thanks to Nurse Nancy for that once again. In studio, we have Aaron with us, and he's with the Water District also. Thank you for coming on today.
Thank you for having me.
So what is your role with the Water District?
So I am the wastewater treatment superintendent, and I'm pretty much in charge of making sure that both of the city's wastewater treatment plants are treating and cleaning the water. so that it goes back into the environment.
Okay, so
Safe.
Yvette talked to us a little bit about that whole process.
Correct.
Where they are, what kind of things go into wastewater, what they do with it, things
Yes.
like that, how it's treated. But you're the one that makes sure that it all gets done.
Correct.
And how long have you been doing this?
So I've been a wastewater superintendent for 2 years or 3 years almost, and I've been in wastewater for about 11 years or 12 years.
Okay, so what are some of the other like entry-level positions, I guess?
So we do have wastewater treatment operators, and I mean we make them start anywhere from operator in training all the way to grade 3 operators.
Okay.
So,
And they're the 2 plants right now,
correct.
and those are the ones you're in charge of?
Yes,
All
the
right.
treatment part of them.
Treatment.
Yeah.
All right. And Yvette really wanted to do a lot of the math problems here, but we said that we were going to let you take care of this part. So Aaron, why don't you go over and we're going to talk a little bit about the mathematics behind the treatment.
Okay, so pretty much we have this problem here where we figure out detention time, because in a primary clarifier, which this is the flow chart. So in a primary clarifier, what we try to do is slow down the water so that it can settle, the heavy material can settle, and the cleaner water can keep going to the next part
Okay,
of the
so you're talking
process.
about slowing down the water. So how
Correct.
fast was it going up to that point?
Well, it depends on our pumps, but usually in the sewer system, it's going about 2 feet per second, and usually we slow it down to about 1 foot per second.
Okay.
Yeah. So in this, for example, in this problem, so we have wastewater plant 3 has 4 primary clarifiers that together receive about 11.5 million gallons per day. Currently, only 2 of the clarifiers are in operation. Each clarifier has a diameter of 80 feet and a depth of 15.7 feet. So to calculate the detention time, we're only going to do it for 2 clarifiers because that's what we're using. And just a quick note, a typical primary clarifier detention time ranges from 1.5 hours to 2.5 hours. And the first thing we have to do is figure out the volume. So to figure out the volume, we take the constant 0.785, which comes from pi r squared. But I mean, since we get diameter in most of our specs, we use 0.785, and then we multiply that times our diameter squared times our height. So if we multiply 0.785 times 80 feet, which is our diameter, and we square that, and then we also multiply it times the height or the depth of the clarifier, we get 78,848 cubic feet per clarifier.
Okay, and we can see because it's a cylinder shape.
Correct.
Right? And 2 of the numbers are already given to you in the problem, right?
Yes.
You've got the 80 feet for the diameter and the depth of 15.7 feet. And then you're just using that other number that you got from pi,
Yeah.
using that, multiplying all of those according to the formula to come up the final volume.
Correct. Yeah, and since we have 2 clarifiers, we're going to multiply our cubic feet by 2, which will give us 157,696 cubic feet. And that, that's cubic feet, so we need gallons of water.
Okay.
So in order to convert it, there's 7.48 gallons of water in 1 cubic feet. So we'll multiply the cubic feet times the 7.48 gallons per cubic feet, which would give us a volume of 1,179,524 gallons. So then we can plug that into our detention time formula, which is volume divided by flow. So we'll have 1,179,524 gallons of volume in the clarifier, and our flow coming in to the plant or to those clarifiers is we'll divide it by 11.5 million gallons per day, and we'll multiply it by 24 hours per day to get it in hours. So if we do all that, we're going to end up with 2.46 hours. So, and that falls in between the detention time ranges.
Yeah, and when you get to that a little over 1 million gallons, when you're converting the cubic feet to gallons, when Yvette was talking about cubic feet of water, that's when she was talking about if you're on a football field and having it up a couple of feet, right?
Yeah, the million gallons would be the...
Right, 1 million gallons. So
Yeah.
that's the amount that you're converting that to as far as
Correct.
getting cubic feet to gallons. And a
Yes.
lot of times that's one of the parts that I think a lot of students get confused with. It's like, how do I get it from cubic feet to gallons? But that's what step 3 is
Yes.
showing right there, converting that.
Correct. Yeah. So
Yeah,
then-
nicely done. So we can see down on the flow chart again, the clarifiers, and those are the cylinders, and which is why we need to figure out the volume of those, and that's the formula for doing those.
Yeah, and just by slowing down the water, I mean, you remove like 90 to 95% of the settleable solids, and about half of the suspended solids, which are the solids that don't settle, and about half or a third of the organic material.
All right.
So, I mean, just by slowing down the water, you get a lot cleaner water to go into the next process.
All right, well, Aaron, come on back over here. I know that was a great explanation of some of the math behind treating that water right there. Now, as far as, because you guys have been in the news a lot, so tell us a little bit about the expansion that's going on.
Well, the expansion, well, both of our plants or plant 2 it has a lot of aging infrastructure.
Okay.
So that one kind of needs an upgrade. The expansion would be for plant 3, which is getting close. It's about 75% of its capacity. So at that point, we have to start planning to expand and to, so that we can treat that flow.
Right, because you don't want more than 75%, right?
Well, by the time you get done with expansion, you're going to be up there at 100%.
And that's
We don't want
why you
that.
need to be doing that,
Correct,
right?
yeah.
All right, so I know everything's going on with the expansions and things like that. If somebody wanted to know a little bit more, website they can go to, the city website?
The city Bakersfieldcity.us.
All right, so it's up on the board right there, so we can see that. So there's times people go, hey, what's the phone number for Do the Math? And after being here for almost 25 years, sometimes I'm like, I know it's 636, something like that. But anyway, Aaron, thank you very much for coming in today. And a little bit about the math right there, and wastewater and things like that. We'll be back with more right after this.
Where do moons come from? Well, they actually can come from a lot of different places. Our moon, for example, we believe formed in a cataclysmic impact between the early Earth and a Mars-sized planet. In just a few moments, this impact would have melted the entire Earth into a lava world, sending thousands of tons of rocks and material into space. Some of these rocks would combine together and form small moonlets, and over time, thousands of years, the moonlets would come together and form our moon that we see today. On the other hand, the Galilean moons of Jupiter are thought to have formed from a giant disk of debris that Jupiter pulled in from the gas and dust that orbited the Sun in the early history of the solar system. The material in that disk would also form those same moonlets that eventually came together to make up the 4 largest moons of Jupiter: Io, Europa, Ganymede, and Callisto. For the last common way moons are thought to originate, we have to look at Neptune's largest moon, Triton. This moon has a very strange orbit, which led us to hypothesize that it was actually a dwarf planet from the Kuiper Belt, just like Pluto. One day it got too close to Neptune and was captured by Neptune's gravity. So where do moons come from? Well, we still have a lot of questions that are unanswered, but with the next generation of scientists and state-of-the-art missions, we hope to be able to answer the secrets of the origins of the moons in our solar system.
All right, in studio we have Colby, a 5th grade student, and I know that in one of your programs in 5th grade, you're studying a lot about space. Mm-hmm. And did you know all of that stuff, or some of that a little bit new about moons and where they come from?
I knew some of it, just not all of it.
Yeah, there you go. I didn't know all of it either, right? So it's always cool to see some new stuff and things like that. There's always something new. I mean, I don't think we will ever run out of something new that we can learn about space, as well as other things. I think the ocean is another one that should be a lot of interest in that also, since it's more accessible.
Yes.
Anyway, do you like math challenges and struggling a little bit?
Sometimes, yeah.
Well, good. You know what? Here's what I want you to do. So what I want you to do, I know every kid goes, sometimes I like to struggle and have a challenge. You're going to want to do that all the time, because the more you struggle and the more you challenge yourself, the more your brain is going to grow, and the more advanced mathematics you'll be able to do, which then in turn allows you to have more options as far as what you want to do when you get a little bit older. So you ready to struggle?
Yep.
All right. So we have a program called Struggly. And with this, the beautiful thing about it is that it doesn't give you any directions or instructions on what to do. You have to figure out what to do. So head on over to the board. You and Mary Lou are going to figure out what you need to do. The only thing that is lit up down at the bottom, we can see there are 2 numbers already lit up. the 2,346 and the 15 at the bottom of the screen. So those two numbers have already been solved.
Okay.
So you have an addition symbol and you've got a bunch of numbers, go to it.
So Colby, what are you thinking? What's happening? How are we getting 15?
Well, you don't
We're
even need to
getting
worry
15.
about that because those
Okay.
are solved.
Okay.
Okay.
Because you can see underneath the 1, 2, 3, 4, 5,
Right.
those ones that are a little lighter, those are the ones that are solved.
Yes, but thinking about the pattern, what
'Cause he's gonna
pattern?
add.
Exactly. What pattern are you seeing?
1, 2, 3, 4, 5.
So we're
On all of them.
adding, like earlier, you just added all those, right? And then here, are we adding again?
Yes.
Okay, so do we want to click on 51 maybe?
15.
51?
Oh, 51.
Let's see, 15?
It's already solved.
Well, let's see if we hit the plus.
Yeah, this is the beautiful thing, right?
This is
'Cause
the
you can't
beautiful
I think we have
select
to hit
which
that
you
one
want.
and then plus it.
Okay. What about this? Ah. Let's see.
You want some help?
Yes.
Okay, so you can't, so I'm just going to help you out a little bit.
Okay.
So these two numbers have already been done,
Right.
as you can see. What you're going to do is you're going to take this and you're going to move it someplace
To try to make
to try to get these
51.
answers. But you can only use
Okay.
those numbers 1, 2, 3, 4, 5 in that order.
So how are we going to make 51? So
Maybe.
so we have to use 1, 2, 3, 4, 5, right? So let's move it in here somewhere. Remember, we can keep adding more plus signs. So let's put it somewhere and start. Okay, you're going to put it there. So right now, let's pull another. Where else are we going to put it?
51.
Oh, there you go. Nice job. Okay,
See, so this one again.
we're trying to get
160.
168.
We just got that from right here. No.
Okay.
So this one, when you get it, I want you to explain it instead of just having it happen by
So
accident.
what are you
Possibly, and explain
doing?
it.
How are you moving this around?
I'm moving around to see, like, you add this sum plus this sum. Like,
Okay.
the smaller sum, the bigger the other part of it is.
Okay, so the bigger part, so you knew that, hey, if I have 123, right, plus 45, I'm going to get to 168.
Yeah.
Okay, hit your check mark. We're now on 1,200.
200.
And I think I saw that come
Yeah.
up.
This one.
There you go. And then let's do 69. What do we think?
69. Probably like right. No. Probably right here.
Okay, we're going to need another.
I can do that. Let's see. Yeah, another one.
Okay, so we need another plus sign. Where do you want to put that?
50.
That's 51. So why are you moving it? Oh, we're closer. How are we going to get 9 out of this? Oh,
Yep.
there you go. Click. Nice job. They're going to give us some more. Here we go. Oh, now we're subtracting.
Okay.
Okay, so the first one is 78. Thinking about your numbers.
No, couldn't be that. Let's
Okay,
Right here, that's 100. Yeah, it's probably right here.
there you go. Okay. 114.
114. 114. Maybe it could be right here.
Okay,
No, that's 78.
that's 78. Well, we got
Oh,
negatives
yes.
now, so let's think about that, and we know that we can't go that way. Do we need another subtraction
Now
sign,
you
maybe?
actually had an answer, but you went by it.
Ooh. Let's try. So if that was,
Okay, so slow down a second.
okay, oh, we got it. Oh, you got
Yeah,
it.
there's one, right?
Okay,
Now 2, 3. So is this one
Okay.
in the negatives?
it's a negative. Ooh, nice one.
Yeah.
Boom. All right.
There you go. Now
Now how are we
you're
going to
on
get
it.
0? What are we going to do to make these numbers
3.
zero out? We're getting closer. So,
Maybe right there. No.
okay. Can we use more than one subtraction sign?
Yes.
Okay. Do you want to try to plug another one in and see? So we're at 27. So think about how,
Yep.
there you go. All right. We got a negative. I think I saw that
yeah,
one.
we saw that one. Was it right here?
Was it with
No,
one?
it was negative.
Okay.
Right there.
Okay. And last one.
1, 2, 2, 9.
Ah, nice.
There you go. Nicely done. So come on over here.
Colby.
So that was just a little bit of a struggle right there, right? Because at first you're like, I don't know what's going on. Where do I
Yeah.
put these things and things
Yep.
like that? So that's why it's called struggling. But once you get the hang of it, you're like, all right, I got this now.
Yep.
All right. So you card player there, young man?
Nope.
All right, you are today. All right. So what we're going to do is the black cards are going to be positive numbers.
Yep.
The red cards are going to be negative numbers.
Okay.
Okay. What you and Mary Lou are going to do is you're going to write the numbers up there as I present them to you.
Yep.
And then you're going to solve the problem.
Okay.
Sound good? And we're going to go kind of fast and see how many of these we can get through.
Okay.
Yep.
All right. So over to the board, each of you will. So Mary Lou, you'll do the one on the left.
Okay.
Colby, you'll do the one in the middle, and then you will have to solve the problem in the equal sign.
Okay.
All right, and then
Ready?
you'll erase them and we'll move on, all right?
Okay.
So Mary Lou, the first number is an ace, which will count as 1. It's positive because it's black.
Okay.
Colby, the next one is a queen, and that's going to be worth 12, a negative 12, because it's red.
Negative.
So what is 1 plus negative 12? Put the answer in the end, and if you need help, Mary Lou's right there.
11.
Ah, how did you know it was negative 11?
Because if it's negatives, it has to add a positive, and then you add the positive to the negative, which gets you 11. And
Okay.
then- well, technically, you subtract it, because
Okay. If we're starting at negative 12, right?
you
And-
subtract it because it's positive, and you go back, like, this is your number line.
Okay.
This is 0. This is 12.
That's our negative 12.
And this
Okay.
is 11. And then, so,
Let me put some negatives there.
yeah, negatives, positive. And then, so, if you have that, you jump 1 over.
Because if it's a positive, we know we're moving to the right.
Yes.
And if it's a negative, we know we're moving to the
Left.
Okay, let's go to the next one.
All right, here we go. Mary Lou, negative 9.
Okay.
Colby, positive 7.
Positive 7.
All right.
So, it's negative 2.
All right. Nice job. Next one.
Let's see, 10, 13, positive. Positive 6.
Positive, well, that's positive 6. Not 16. What is it? 13 plus 6 equals 19.
19. All right.
Positive.
See, some of
go.
it may be quick and easy, right? Mary Lou, negative 8. Colby, positive 3.
Positive 3. Negative 5.
All right, here we go. Mary Lou, negative 8. Colby, positive 11.
Positive 11. Positive 3.
So why this time is it positive and not negative?
Because you have more of the positive than the negative, and then you just subtract it.
Perfect.
You ready to keep rolling?
Yep.
All right, here we go. Negative 10. Positive 7.
Positive 7. Negative 3.
There you go.
12, positive.
My
Negative
favorite
1.
number.
Negative 1.
Oh, it's like where we started,
11. Yep.
right?
Whoa,
Well, positive, positive.
Thank you.
Positive.
don't be going too fast.
Yeah, and now really quickly we can talk about absolute value because we started with negative 11 and now we have positive 11. We talk absolute value, right?
Yeah.
Thinking about those because both can go to 0.
Now, hold on a second, because you bring something interesting up, right? Absolute value. Have you ever heard of the term absolute value before?
No.
Excellent. Mary Lou, I'm going to give you a minute to go over absolute value.
All right, so absolute value is, I'm going to put our positive 11 here, I'm going to put our negative 11 here. Absolute value is how far away from 0 are you? Okay. So how far away from 0 am I from negative 11 to 0? How far away am I?
11.
I'm just 11 away, right? How far am I away from 0 and positive 11?
11.
I'm still 11. So when we talk about absolute value, we show it as these brackets are straight. They're not curved like that we talked earlier. So no matter if I put this says what is the absolute value of negative 11? How far away from negative 11 is 0? And you told me it's 11 away. And then we also have 11. What's the absolute value of 11? is still 11 because we're saying what's the distance to 0?
Yeah.
That's absolute value.
There you go, nicely done. So I know you learned a little something with absolute value right there. You ready? We're going to get through this deck?
Yep.
Attaboy. All right, positive 2,
Okay.
negative 12,
Negative 12. Positive 2, negative 12, negative 10.
All right.
negative 3, positive 6,
Positive 6. Positive 3.
Got it.
positive 5, negative 4,
Negative 4 equals 1.
Okay.
negative 10, negative 13,
13.
Ooh. Negative? What happens? This is the first we've had 2 negative numbers.
You add them, and then it's negative 23.
Negative 20.
That's funny how it
Nicely
came out to be
done.
23, one of our favorite numbers here on
Yes.
Do the Math.
Yes,
this
it
happens
is.
to be
Whoop,
negative
whoop.
right there, though. All right, here we go. Negative 9, positive 8.
Positive 8. It's negative 1.
All right,
Hey.
we're almost through it. Negative 4, positive 9,
Positive 9. Positive 5.
Okay.
positive 4, positive 10,
10. 14.
negative 6, positive 11,
Positive 11. Positive 5.
Okay.
positive 1, positive 8,
Positive 8. 9.
negative 13, positive 2,
Negative 13. Positive 2. Negative 11.
Ended up with our negative 11 again.
and negative 11,
Haha.
positive 5.
Positive 5. Negative 6.
Okay.
You feel pretty good about that? Dude, you're on a roll.
I know.
And I'm glad that you're able to kind of get through those pretty
did
quickly.
that really good.
They're just low numbers, but it's the same thing that you're going to do when you get larger numbers. But just remember that positive negative thing, right?
Yes.
And when you multiply, it's a little different,
Yes.
but we'll get to that another time, all right? Good.
Nicely
Nice
done.
done. Hey, we'll be back with more right after this.
Tardigrades are interesting because they're an animal species that are so small that they generally can't be seen with the naked eye. So tardigrades are commonly called water bear, and they are associated with a wide variety of environments, and notably challenging environments. So they can live under conditions of extreme coldness, and they can regulate their metabolism. So they're a class of organisms that are linked with others called extremophiles. They can live in extreme environments, such as in Arctic environments. And indeed, as animals, these extremophiles can regulate their metabolism. They can slow down their metabolism to the point where they can remain in essentially suspended animation for long periods of time. Now, this is interesting and personally in a number of different ways, in that I was involved in a project that took molecular components of extremophiles and took advantage of some of their properties by integrating extremophile molecules and biomolecules with microelectronics for sensor applications. Here at NSF, the Engineering Research Center supports a program called ATP Bio, and the goal of this is to use some of these same extremophile concepts to take tissues, including human tissues, and slow down the metabolism by placing them under freezing conditions and essentially stop biological time, stop the clock. So if we could take some of our tissue, some of our valuable tissue, stop biological time and put it in a freezer, and then reanimate it, we would have a profound solution to individualized medicine and to worldwide problems involved with the transport of organs for transplantation and many, many other things. In their own way, aside from being an internet muse, have a way of painting an analogy to how we can use these concepts of extremophiles for a very important societal problem.
All right, we have Colby, a 5th grade student from Stockdale, in studio with us today, doing a lot of prime numbers, negative numbers, integers, things like that. A lot of stuff going on today, right? You even learned a little bit about absolute value.
Yep.
You ready to try a little something new?
Yep.
All right, over to the board. So you were looking at, you're like WODB, that means which one doesn't belong.
Oh, okay.
All right, so take a look at the 4 of those. Explain to Mary Lou each one what you're looking at, and you decide which one of those doesn't belong and why.
Well, let's see. This one is 5 plus -3, which equals +2.
Okay.
And then this one equals +2 as well.
Okay.
And then this one is -2. And then this one's just 2. So this one doesn't belong
Why?
because all the other ones are positives, +2s, and this one's -2.
Okay, so now I'm going to challenge you,
Yep.
and I'm going to call it tie for 2.
Okay.
So which 2 can belong together?
Which 2? Oh, these 2.
Why do these 2 belong together?
Because they both have a -3 and a +5. This one just has 5 minus 3.
Okay, so these, and you see that these 2 both have a plus sign.
Now, hold
Okay.
on. Yeah, go. You know where I'm going with this.
Yeah.
Yeah.
So now I'm going to ask you, which 3? Can there be 3 that belong together?
These,
And why do those 3 belong together?
because they all have +2 and that one has -1.
Okay, now I'm going to ask you, why do all 4 belong together? What do they
Because-
all have in common?
5 and 3.
5 and 3. They all have 5 and 3? Okay, in common. If I asked you not to solve that, because I know you solved all of them, just looking at this, what would you say doesn't belong?
Probably that one.
Which one? This
That
one?
one, yeah.
Okay, why? Why would that
Because
not
it
belong?
has no symbols.
Oh, it has no symbols. Whereas here we see our positive and we see a negative. But here, really, and then all 3 of those, I see an addition sign. So when I say what 3 belong together, in my brain, I'm seeing those 3 because they all 3 have positive signs, right? But yet that one does not. That has your
Right, and I was going to say that's another way of looking
Yeah.
at it, because I would say that one doesn't belong because there's no addition symbol.
Exactly.
But if we take a look, you were like, it doesn't have any symbols. It does. It has a subtraction
Yes.
symbol in it.
Because
And if there's no symbol in front of a number, it's
None of
implied
them by
that
the
it's positive.
numbers.
right there. So how are these 2 the same?
It's really, if you just take this out, they're the same.
They're
And
the
then
same?
and then you put the negative symbol right there, they're the same thing.
So we can rewrite this
Yeah,
as 5
5
minus
minus 3.
How can I rewrite that?
You could do this, and then put the negative right there.
And then what would happen to the, oh, here?
Oh yeah, it'd be positive.
Yeah, because this, if we had this, would we have the same answer?
Yes. Wait. No.
What happens because I have a negative followed by a negative, right? So this is saying what is the opposite of this?
Yeah.
Right?
Yeah.
And the opposite of that would be
All right, so
positive.
solve that one. What is 5 minus negative 3?
-8.
Is it -8? So I want the opposite of that. What's the opposite? This is 5. This is 5. Give me the opposite of -3, right? So we have a
+3.
so we have a positive, right? So we're really saying negative. We're making that into a
There you
Positive
go.
plus sign.
Nicely done. So, Colby, did you learn a little something today?
Yep.
Good. A lot of stuff, as a matter of fact, I think you did, right? Did you have fun today?
Yes.
That's the most important thing. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, California Resources Corporation, Edison International, Center for Neural Skills, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, Tuolumne County Superintendent of Schools, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education.